All right, this is the first topic of reactor theory. It's entitled neutrons. Now, there's some foundational stuff in the front of this, and we actually start talking about neutrons around section 3 or 4. But I will tell you that there is not a more important topic for understanding all of the other 7 topics. So this topic is going to lay the groundwork and develop the language that you need to know to understand what's going on in the other 7 topics. So we'll be talking about neutrons, tons and tons of things and characteristics of a neutron that are very important. All right? So I'm going to come right here. You can see it's neutrons, topic 1. And we're starting here on the introduction. Now, the introduction there discusses about things about matter and how the Greeks, these old Greeks, thousands of years ago, that they speculated that the earth was made of these substances or elements, and that you could further break a substance down until you only had strictly identifiable different elements. Great, we all know this. So as you go on over on the right-hand side of this, it's just historical in nature here, but over on the right-hand side, it starts defining stuff that matter to us more in this lecture. It lays out what the 3 particles are of an atom. And we know we have an electron that goes around a nucleus. And this is our nucleus. And in this nucleus, I'm going to put 2 neutrons and 2 protons. So this is a model that we'll use for atomic structures. And in this case, since I have 2 protons, I've made a model of helium. So I need another electron to make it electrostatically neutral, because if I have 2 protons, if I don't want it to be charged, I need 2 electrons. And some things we learned about this. We need to be able to make measurements of these very small things. So we're going to measure the mass of electrons and the mass of neutrons and the mass of protons. How would I measure their mass? Well, we're going to use a unit called the atomic mass unit. And it's equal to 1/12 the mass of, of 6 carbon-12. You might ask yourself why 6 carbon-12 was chosen. 6 carbon-12 is the most abundant isotope on Earth. And that's by number, by mass, actually. This is an interesting note. By mass, the most abundant is 26 iron 56. That's by mass, it's the most abundant on Earth. 26 iron 56. That's going to be a very important isotope of iron that we're going to be looking at here later on. But so all this atomic mass unit is it gives us the ability to have a unit of measurement for mass of a neutron, of a proton, and an electron. If you kind of want to try and get your arms around what one atomic mass unit is, and you see that it essentially is the 1/12 the mass of all the neutrons and protons in a carbon atom. It's the average mass of the neutrons and protons in a 6 carbon-12 atom, which isn't very much. It's essentially the mass of 1 neutron or 1 proton. And 1 atomic mass unit, just so you can see how small it really is equal to about 1.66 times 10, look at this exponent, minus 24th grams. So we're talking a very small amount of mass here, and we should be. We're talking about a single nucleon. A nucleon is a proton or a neutron. That is a nucleon. Nucleon. It's protons, neutrons. They're both nucleons. All right? On the bottom of this page, you will see some different characteristics of our 3 elements there of an atom. And you'll see that a neutron, right here on the bottom, a neutron, we all know, doesn't have any charge, and it has a mass of approximately 1 atomic mass unit. It's not exactly 1, and it's going to be important what that real mass number is later on. We can look at a proton. A proton carries a charge of +1, and its mass, it too, has about 1 atomic mass unit. Very similar. There's a slight difference between the mass, though, of a proton and a neutron. And then finally, an electron has a -1 charge, the exact opposite charge of a proton. And let's look how tiny its mass is. 1/1800th. 1/1800th of an atomic mass unit. It would take 1,800 electrons to equal the mass of a proton or a neutron. That's pretty interesting. So let's go on. In the upper left-hand portion of the next page here, section 1.4 here, it introduces these three elements, the proton, the neutron, and the electron. And it states their charge, and it also discusses how electrons orbit the nucleus. They orbit the nucleus in concentric orbits called shells. And the discussion of those shells and the characteristics of what happens as those shells are filled or not filled, that's where chemistry comes in. And we're not going to talk about much chemistry when we're talking about reactor theory. We're mostly going to be talking about what's going on inside the nucleus rather than out here with the electrons. This is chemistry. This is going to be reactor theory stuff. But this is an example of Bohr's model. And in this case, if yours is colored, you'll see that there are 3 protons in there. 3 protons and 7 total nucleons. So if you are familiar with that, I would write that as 3, and I just happen to know if I have 3 protons, I know that that's lithium, and there's a total number of nucleons of 7. And this is called ZXA notation, which we're going to get to in the next lecture. ZXA notation.